we come across. We got a record of it, and we can go back to and look at it. All right, so we're going to go through. Basically, what I want to go back to is this cheat sheet here, which is great. This is a fantastic cheat sheet, and probably I'd like to write my own cheat sheet just for my own purposes, not to share with others, although I might do that. But and this cheat sheet is fantastic. It's old though. It's what is it? It's October 2014. Well, it's not that old, is it? It's pretty recent, but it's the older version. Oh, last update, January 2015. Maybe that's after the update happened. I don't know. So let me go through this again here. I'm going to redo stuff. I'm going to make a folder to work in. I'll call it test, and I'll cd into that test. I want to create a index.html file. This is the simplest way to create lots of little examples. And I found that all you got to do is stick a script element in there. Sorry, what's going on there? Not working. How am I am frozen up here. There we go. So just stick a script element in there and start firing away. And this is absolutely for phaser development. This is the most useful. This is the most useful JavaScript statement that I found. Because I just go here and pop this window open, and this is called a console tab, I guess. And I'm going to start up the server. And I'm going to kill that because I want to do it in a separate tab here, so I don't have to tab through it all the time. There we go. Go back to there. Test, we call it test. So here we have an index.html file, so we can request that thing. So localhost, I'm at this 1989/test. See that? It says OK. That's it. See that? That's we're printing OK. That's the OK that we printed right there. And what's that next line there? What's that error message about? Anyone can explain that?
Your favicon is not found.
Yeah.
It's a little icon next to the local host.
That's right. It's this icon up there. But why is it even looking for it?
It's a default setting.
It's a default. The browser just says, I'm going to look for a favicon. So when you're building like a site to go public, it's good to have a favicon file because the browsers are going to look for it. I don't refer to it anywhere. I don't refer to it in my HTML file, but I'm getting this this failed 404, this HTTP error code coming back because the browser's requesting that. So it's good in a polished site to have a favicon there, and then it'll show up here. So anyway, that's that test, and we see the OK. And now, before we forget, I'll forget and show you what happens. What we'll do is we're going to create that game object. So we're going to do new phaser.game. Look at that. Creating that game object. And then we'll dump out that game object, see what it looks like. Now, this is going to fail because, right? Anybody know why it's going to fail? Just to show you. Huh?
There's no instance of phaser?
Yeah, there's no instance of phaser. That's right. Good. Yeah, I'm glad you're following there. See, you're the only guy not using a computer. You're the guy that's paying attention.
You're distracted.
I use my computer when I'm eating dinner. I'm terribly distracted. So I just assume everyone's going to be using, like everyone, except for Jamie. And you're not using yours because you're low on battery. But I come from the past where this is crazy. Everyone's staring at their devices all the time. It's weird. It's a science fiction movie we're living in here. All right, so phaser is not defined, so we got to bring it in, and this I think is just so easy. Just drop that line in there, and hey, you missed it. Kukuru.
Yeah.
We started without you because you're late.
Yeah.
Yeah. Okay, so you can go next week. Okay. You can go next week.
Okay.
All right.
But I thought you said me I should presentation next week.
Oh, I thought it was today. Oh, okay. Oh, good. All right, so harmless misunderstanding. All right, so next week, maybe Tuesday. Tuesday? Okay. All right, so now phaser is defined. And look, this is the default size. See that canvas right there? That's the default canvas, and I'll show you that. If I go over to elements, I can see the canvas, width 800, height 600. That's the default height and width. And we can also look at it here, because look, I'm printing this game object. See that? So I get a nice version of that. And if you look at there's a width of 800, the height is 600. Now that starts in an underscore. So there should be width and height without an underscore, I believe. There it is. There's the width without an underscore. Here's the width with an underscore. Now, what is the difference? Why do they have both of those in there? I don't know. You'd have to open the source code and start reading it and see what they're doing. Why do they have both of those set? So we don't know. So mark that as something that we don't know. So now if we want to change the width and height, we're going to specify the width first. And I'm going to give it a width of 64 and width of 256 and a height of 64. And then there's that rendering system, and the default is phaser.auto, but we can just omit that. I believe we don't even have to put that in there. So it searches for the best underlying rendering system. If it finds WebGL, it's going to use WebGL. And more browsers are supporting WebGL. Things are slow on the mobile devices. Kukuru, do they support WebGL on Android browser?
What?
Android browser, does that support WebGL?
Most of browsers support WebGL.
On the phones and cell phone?
Yes. But some of function is not supported. For example, dynamic text update is not supported by Android.
Which one?
Dynamic text update.
Oh, some features of WebGL are not supported, like dynamic texture update.
Yeah.
Where is can I use? I don't get it. Can I use.com? Is that what it is? There it is. So WebGL, this is good. This shows you, this site is fantastic. You really need this kind of thing. So it shows you how the support for WebGL. And look, Internet Explorer version 11 is supporting it, but version 10 does not. Firefox, Chrome, Safari, and you got some color coding there, right? So it's not full support. Where's the color? Oh, there it is. Green is supported. Red is not supported. This olive green is partial support. Gray is support unknown. So partial support on Firefox. And it also gives you, look at these statistics. Oh, these are the future versions. Look at the browser usage. Global browser usage, 0.27% of all users, all browser users are using Firefox version 37. We go back to 7%, 1%.
You can show the graph. It is efficient to describe user rate, usage related.
Oh, right there?
Yeah.
Oh, look at that. Yeah, really cool. Never clicked that button before. So look at Chrome. Chrome is huge.
Yeah.
Yeah.
Holy cow.
Chrome for Android too.
And see, Chrome for Android, you see partial support, and Android browser is no support. You know, there's a difference. You got to install Chrome.
So
Yes,
you can get your phone.
I don't know why they don't have a normal Android browser. I don't get it, but iOS is supporting it now in version 8.3, and there's still some holdouts there in the old section. Opera Mini is not supporting. So, you know, if you do an application that relies on WebGL, then this is the kind of coverage you're going to get. You're going to get people that are in the red here. It's going to fail. And if you want to reach these other groups like Firefox users and Chrome for Android, then you got to go and study what the limitations are, because they have partial support. So what can't they do? And then you have to avoid what they can't do. And then you'll be covered on these platforms as well. And this is great. They have these notes here. Oh, look at this. Support listed as partial refers to the fact that not all users of these browsers have WebGL access. This is due to the additional requirement for users to have up-to-date video drivers. This problem was solved in Chrome on Windows as of version 18. Isn't that interesting? So it has to do with the users may have Chrome for Android, but they don't have an up-to-date video driver. And that seems like that's essentially the problem with partial, giving partial support there. And here's some known issues, some resources. So this is very helpful. Let's come back here. And let's go ahead and save this. See, the background is smaller. That's 256 pixels this way, 64 pixels high. All right, now, this is the game object. When we create this game object, we create that canvas element. We didn't name the element, so it generated one for us. I'm reviewing stuff now. If you look here, there's the canvas element. It didn't attach an ID. So there's no way for us to refer to it. Well, there is. I mean, we could search for a single canvas element in the DOM, but you know that's one way to do it. So creating this game instance resulted in a canvas element being created and being added to the body of the HTML document that we're working in. So that's there. All right, now the thing about the game is you've got the game we transition between states. So let's do maybe call it a init state. Maybe we'll call it an init state, and I'm just going to call it like this. This is the init state, initial state, and I'm going to use this sort of format here. Now there's functions on it. For instance, there's the preload function. I think is that an uppercase L or is it a lowercase? I can't remember. I think it might be lowercase. So we're defining this preload function that's a member of the init state. So here we create an instance of the init state as a simple object. Now we're attaching an attribute called preload and setting it equal to this function. And of course we'll use our handy log function here. And just to print out the word preload. That'll help us, and then we'll know whether we're spelling this right or not. I don't know if that L is capitalized. I don't think it is. So let's, of course, this isn't going to do anything because we need to start the state. So I have this game class, and it has a field in it called state, and that's an instance of the state manager class. Just to show you what's going on there. This is Phaser docs. So this game class here has got some properties. And one of the properties is state right there. You see this? That's a public property of the game class. And if I follow that out, I can see that state is an instance of phaser.stateManager. All right? That's an instance of state manager. Now this state manager has a function which is add. I want to add a state to the state manager. It doesn't make it active, it just creates the state. So we're going to add a init state. Actually, there's many different ways of doing it. I'm going to show you two different ways of doing this. We're going to add this init state. And, but adding it doesn't make it active. Oh, we have to name it, by the way. I'll call it init. There we go. After we add it, then we can start it. We start it by the name that we gave to it. So we changed the name here. We're going to change the name there. Now this should start it for us in a moment. It starts it. The preload method will be called. We're going to print preload. Let's see if that works. There's the preload right there. So we get that working. But I want to show you a different way to do this. So here we're passing in a simple object. So it simply says, oh, it's a state you've already been created. So we're not going to instantiate you, but you can pass in a function here, and then that function, Phaser will detect that it's a function, and it will use the new operator to create an instance. Using that function as a constructor, we'll create a new instance and use that as the state. I'm not going to get into that. It's going to get really messy. Okay, it was super messy. I'm not going to show you that. I can do that later if you're interested, but I don't think it's that necessary. But when you see some example code, you see the people running those examples. That's how they do it. Once again, this add function, when you call this add function, the add function checks this. Here, we're not passing in a function. So it says, oh, okay, so that means you're passing in what you want me to use as the state object. So it just uses this pre-created state object. But actually, it does this thing called, what's the word? Keep forgetting this word. You know, it copies the properties. It populates this init state with a whole bunch of properties and, from another object. What's that called? Mixin. You know mixin? In JavaScript, they call that a mixin. So a mixin is where it's an alternative to inheritance. You take these two objects and you want the properties of another object to, in a sense, be inherited by this first object. So you could make it the prototype object and then it just inherits everything that way. Or you can just you can clone all those properties of that other object and add them to this destination object. And they call that a mixin.
So like when we change states, it'd be kind of like going to a new level, and like say if you have a character, you could copy the character's objects all over.
Well,
the attributes.
Yeah, maybe.
Like, you know, like if you have
Maybe,
stats
yeah.
and stuff for the character, that would transfer over to the new level or something.
Yeah, then it might be handy to use some of this more elaborate stuff that we're talking about.
Because then you maybe want to alter them in the new state, right?
Yeah.
After you.
So we could do that. We can do it manually when we do the state transition, or else we can do some kind of fancy coding that relies on, you know, Phaser's mix-in facilities and whatever.
Because so far, I think like some of the assignments they haven't really dealt with state changes. We've just been doing.
Yeah. But I think state changes are basic and fundamental, so that's why I'm spending a lot of time on them, because I think you got to know this. I don't see any other way to build a game unless you use these states. Anything other than a very, very simple game. I'd say the game I'm envisioning is kind of like a side scroller. You would have different rooms, and each room is its own state.
Okay, that's what I wanted to do.
Yeah, that's what I want to do. So yeah, let's do it. Let's make it work. Anyway, here's the init state. We can do that today, actually. Let's set it up. We'll create a character and have it move to a door, and then transition to another room. Let's see if we can get that done. All right, so what was I going to say here? Oh yeah, let's do something. Let's do stuff. And look how simple this is. You know, I just have one file, index.html. You know, that's all I have in there. That's it. So I can start testing with phaser. Of course, I am running through the web server, right, the local web server. And if I didn't do that, what would happen? Watch this. Let's just open it up directly, see? And, well, it seems to be working all right. But there's some limitations, and maybe we're going to, so here we're not going through the web server. We're reading from the file system. Here we're going through the web server. Localhost, port 1989. Yeah, Jamie.
When I tried doing that, I couldn't load any graphics when I loaded
Yeah,
HTML.
that's where I'm headed.
Same thing.
I'm going to, you set the punchline before I was able to deliver. Okay, that's exactly it. So we can't ultimately use this. In a limited way, we can use this load from the file system. But when we start trying to load other assets, there's the browser security features or restrictions are going to get in the way. And we're going to be forced to load through a locally running web server. So I'm using Node for to run locally, but you can use anything. Any kind of web server you want. Python's got a nice web server built into it. Just use whatever you're comfortable with. So what I want to do is copy from here. And this thing, we looked at this last time. This is this expanding dot here. See that? It's called a dot. And let's take a look at that dot. That's what the dot looks like. This image is 256 pixels this way, 64 pixels up and down. So basically I got 4 frames, and I'm going to make an animation so that the dot is pulsing. We saw this a while ago, so I'm going to do this quickly. We're going to review this, so just reviewing. So what we do in the preload function is we do this dot load, and I'm going to start with image. I'm just going to show you with an image here. We can load that thing as an image. Now that thing is 256 by 64, right? So I'm just going to make it a little. I'm going to double its height there, okay? Oh no, sorry, double the width and double the height. And then we're going to load this. We're going to load that as an image, and we're going to call it dot. So the first argument is the key that we want to assign to it. The second argument is the path to the resource. So it's dot.png. And then in the following, when preload completes, then we have the create function that gets called. And this create function, we're going to use this dot add dot image, and we're going to put it in position 24, 24, and name the image, which is dot. So that'll render the image for us at 24, 24. There it is, when it can't find it. Loading asset. Texture with key dot not found. What the heck?
You didn't put the is it in that same folder?
Huh?
Is the second part where dot.png does that image immediately in the root folder?
Yeah, it's right here.
Oh,
See, there it is. Index HTML dot.png. Does the key follow the name? Did I have this backwards?
Wait, do you have the image part backwards? Shouldn't be dot and then 24, 24.
I don't think so.
I think he's right.
I don't think so. It's easier to do this than look in the documentation. Phaser loader, error, loading asset from URL, dot.png, cannot read property has loaded of undefined. What the heck? What is going on? All right, I'm gonna go to the cheat sheet. All right, managing game assets. Loading an image. Game.load.image. This.load.image. And I want to talk about that in a minute. Key and then the path. So the key does come first.
That's right.
So we got that right. Oh, wait. Is this, so we're under test. Look at it, watch this. We gotta put this one back to where it was. All right, and I want to get rid of that. This is the way we had it. Look. This is really subtle. See that slash? I'm going to take that slash out. An error. Put the slash in there. I don't get an error. What is going on?
That's the file directory.
Because here, when I ask for test, see, because my web server is running, what it does is says, I'm going to return, let me show you this. This is here, the this configuration right there. I was saying if someone just asks for the root folder, just return index.html. Don't redirect them to it. So we're not redirecting the browser. See this is what's being loaded. That's what's being loaded, see? But if we just ask for the root folder, the web server says, well, I'm going to just send you index.html because you told me to do that with this configuration. So this is the default name for the file that's returned for request to a folder. If you just send a web server a request for a folder, give me a folder, it's going to return you, it's going to look inside the folder, find an index.html file, and send that to you. That is the default behavior of a web server. Some web servers will not have that as their default behavior, and then you have to configure the web server to do that. This Node.js server here, this live node module ST, you need to configure it. So, and I did configure it. But it does one more thing. So we ask for the folder, and it sends the context of index.html. But if I ask for the folder without the slash, I'm still asking for the folder, and it still sends, index.html. Look, I show it to you there, right? It's going to be in there. No, that's not it. Yeah, there it is. It's still there, right? There's the index.html file. And but it says that it can't find the asset dot. You know why? Because it's looking for this becomes because this is a relative path. Let me get rid of that. This is a relative path. It's relative to this URL. So what it's doing is it's looking for this. See? And it's saying, can't find it. And that's why if we add the slash, see? If we add the slash, it says, oh, I'm in a folder. Because when I requesting test without the slash, the browser says, oh, you're not requesting. The browser doesn't know it's a folder. It's the web server that knows it's a folder. When we ask for test by itself, the browser says, oh, test is just, it's a resource, a name of a resource, like a file. And everything is, and that file or that resource is under this sort of path. But if we add a slash, we're telling the browser, hey, test is a folder. And we're going to retrieve the default, object for request to the folder, so that when there's a relative request like this, that it knows to look for it under that folder. Is this clear, you guys? You know, these are some really subtle, when you're doing web development, there's some really subtle gotchas, and this is one of them, okay? This confuses people. Yeah, it takes some time to remember those kind of things. So anyway, there's the image. Now we're going to make that into an animation. And what we do there is we don't want to load it as an image. We want to load it as a sprite sheet. So it's a sheet with sprites in it. Yeah, Jamie, what do
Can you
you?
explain the difference between using this and using game?
Oh yeah, I was going to do that. I was going to do that. All right, let me tell you. Let's go back. This is refers to the function is the object that this function is running against. So this is so it'll be like init state.preload. It's like calling, you know, it looks something like this. Init state.preload. It's like we're calling it like that. See. So when we call it like that, that means init state is this. So this function is running relative to this, you know, object init state. So this refers to the object that the function is running against. That's okay?
Yeah, so in bottom where it says game.state.start, can you put this state.start?
I don't think so. Well, this would, in this point here, we're in the global namespace, see? So this would refer to the window object, which is the global object for on browsers. So this won't work here. we can do this dot game because at this point in this script, you know, this equals this thing called window. In JavaScript, you have what's called the global object, and the attributes of the global object are the things which are in the global namespace. So see when we created var game here, we didn't create it inside of a function. It's not an attribute of any object, so it becomes a member of the global namespace. So what happens is it becomes an attribute of this window object. So this dot game. See this when we do this here, game becomes an attribute of this global window object. And I'll show that to you right here. This should be true, and that should be there's the true right there, see it? And then this is the instance of game. You see that? So that's how JavaScript works. But let me tell you that when we call start right there on the init state, init refers to this guy that got created here and populated with these functions, all right? So when we call start on this init object, what the start method does is it populates this init state object with a whole bunch of useful things. One of them being the load object and the add object, which it simply copies from the game object. So when this guy runs here, this this dot load is identical to game dot load. They just got copied over. They referred. It's a reference, by the way. This load, we didn't copy the whole object. We copied a reference. So in JavaScript, everything's a pointer. It's like Java or C#. Things are pointers, unless it's a primitive data type, you know, like a number. Then it's a copy. So so load in this in the game object, that when we start this state here, this start method grabs this pointer, game.load, as a pointer, points to this loader instance. It gets that pointer and it creates another attribute of our init state. Another way to write this. This is equivalent because the init state is when we're in here, init state is this. You guys getting just hammering this out so you guys get this. See, because preload is being called against the init state instance, so that means this equals the init state. And the init state has a load reference, which is the same as the load reference in the game object, because the start method stuck it there for us as a convenience. So in the phaser documentation, they use, whenever you see the word context, they're asking for the thing that's going to be operate as the this reference. So when you see in the API and it looks like a function takes a context, you know that the function's code internal to that function is going to have references to this. And it's asking you, what do you want me to use for this? So that's what, when it uses the word context as one of its attributes, that's what it means. And let's see if I got all that right. Should be a whole bunch of truths there. I got it. All right. I know it's confusing, right? That's pretty confusing, right? So I just showed you a bunch of experiments. You got to do those at home to really nail it in. And then you'll be a JavaScript master. You got to do this stuff to really master the language. This is crazy. It's different. In C#, Java, C++, this is something that's much simpler to think about. In JavaScript, this is a very flexible keyword reference. And it doesn't always refer to the thing you think it refers to. So you need to sort of be aware of that. You can modify what this refers to. All right, so what am I doing here? Oh yeah, now I'm going to go into, that was long-winded, sprite sheet. We're going to load this dot image not as an image. We're going to load it as a sprite sheet. And then we're going to tell Phaser that it's the cells are 64 by 64. And just go ahead and split it up evenly into cells that are 64 by 64. And now we're going to add this as a sprite, not as an image. Actually, an image, I believe, is some kind of a sprite instance anyway. And let's store this. I'm going to call it dot. And I know where I'm going because I played around with this morning. Let's just define dot up here, okay? So we load the sprite sheet here. It's loaded as a raw asset that we refer to with the key dot. We take a reference to that raw asset, dot, and pass it into this factory function called sprite. And that spits out an instance of the sprite class. And this sprite will appear at position 2424. Now let's take a look at that. There it is. There's the dot, okay? But now let's make it pulse. We're going to need to look at its animations. And it has a function called animations. And it's an instance of Animation Manager, I believe. And Animation Manager has an add method. I think it has an add method. Now we give the name of the animation, and I'm going to call it pulse. And then we have to tell it what frames from that sprite sheet we want, and what's the sequence of frames that comprise this animation. So it's frame 0, frame 1, frame 2, frame 3, then back down in the opposite direction. And then there's the frame rate, 10 frames per second, and then there is whether it's looping, and it is looping, so it's going to have to do that. So now we define an animation called pulse. Now we're going to make the pulse animation active. So we do dot animations dot, I think it's start, and then we just just the animation that we named, which is pulse. Let's try that. Should be pulsing. It is not pulsing. Start is not a function. Oh, play, I think. Maybe it's play. That's, look at that's faster than looking up the documentation, isn't it? So, finally, after all these years of being a professor, I realized the students were right all along. Forget the documentation.
Just try.
Guess your way there.
It's always a 50-50.
I've seen the light. All right, so that's the pulse. Now, what we're going to do is mess around with the physics system. And there's a whole bunch of physics systems. Yeah, let's see that. There it is. So if you look down here, it's got physics, physics section, and there's this arcade instance. This thing here is created by default, and it exists with your game object. But you can create an instance of the physics or the Ninja physics system if you want. And when you do that, then this thing gets created. And or you can do P2, and that gets created there. And then there's Box 2D, which is not listed there, I think. And but once again, that's a commercial product. Box 2D, that's Angry Birds, it uses Box 2D. Box 2D, I think, was a big open source 2D physics engine that's been widely used over the years. I think the guy's trying to make a little money now after giving it all away and seeing Angry Birds make billions. He's like, I want a little bit of that. So, let's see, physics.p2. So what you do there is we need to do something. What is it? I cannot remember. Let's use the cheat sheet on that. Where is that physics? And it's down here, I guess. There we go. Well, we got to call it game.physics.startSystem. So let's do that. I guess we do it in create, I'm not sure. Maybe we can do it in preload. Maybe we can do it in a init. Let's do it in a init just to see if we can break it. If we don't break it, then we know it works. So there's a init. Remember, init runs before preload. And it just separates things out a little bit. So we're going to do game. Actually, I think we can run this. This.physics start system phaser dot p2js. That's the name of it. Phaser.physics. Whoops, we need a .physics there. p2.js. So it must be. We look for that p2js. I did not do this yet. Look at that. This is it right there. JavaScript 2D physics library. So this has been, incorporated into Phaser directly. Unlike Box 2D, which has to be attached separately. So that the license for this library must be very liberal, very free, so that another open source developer like, Phaser would be able to assimilate this physics system right inside of its source code. So that's a very liberal license. And those kind of licenses are, open source projects that have those very liberal licenses have very wide coverage. And they're very widely used because you can do anything. Commercial developers aren't afraid of them, so they become very useful. But these guys aren't making any money, so that's a trade-off. It's either fame or fortune, which one you want. So we initialize this thing. You got to go. See you later. Okay. So now what do we do? we start it up, and then we've got these things like this dot sprite that we added. What we do is we add it into the physics system. So this dot physics dot p2. See, this attribute gets created when we start that system up here. And we're going to call, I think it's add. We just add this dot. I think that's the syntax. Let's just do it. That's not a function. So let's go back to here. I guessed wrong. And let's go back to the cheat sheet. Oh, enable. Got to use enable. Game.physics.enable. Game.physics enable, and it is sprite, comma, name of the engine. So this would be phaser.physics.p2js. There we go. There, like it has some kind of initial velocity even, just floating around here. And it's restricted inside the world, which I think is the default setting. Now we could give it a velocity. Let's do this. Let me show you this. We're going to enable physics on that. Let's do this. Let's create a handler function. When we click, we'll move the ball to the click point there. So it's this dot input dot on down. We did this last time. That's an instance. That's called a phaser signal, which is activated when we do a mouse click or I think a tap on a phone. And so we're going to add a function, a callback, which gets the a mouse reference and the event object. We need to pass in a context to that. I just remember I looked at it this morning, so I got it in my head. And you can look that up and see that. So let's just test that we got that right. So console.log click. Let's click the mouse, see if it says click for us. Ready? Oh, something's wrong there. This, we need to use a parenthesis there. Ready? I'm going to click, and it says click. Got it? So we got that working. So now what we'll do is we're going to reposition this dot. So the dot has a body object. Now this body object doesn't exist until you enable physics on it. So that line there and causes an attribute named body to be added to this sprite object called dot. And then it has a velocity. And we can set the x velocity to something like 10. I think that's pixels per second. Let's see if we got that right. Oh, I'm sorry. I didn't want to do that. That's a position, isn't it? This is, I didn't want to do this. That's not what I wanted to do. Just the x value. I want to make the x value the, sorry, I forgot what I was doing. I want to move it to where we click. So it's client x. And we looked at this last time. And so the y value is e.client_y. So let's see if we can move that dot. Okay, there. See how it works? Now let's give it some gravity. Watch this. After we can assign gravity to the whole world, or we can assign it to the object itself. So let's do it for the whole world. So I'm going to do it up here. That's what I did this morning anyway. So it's this dot physics dot p2 dot gravity dot y, and we'll give it some positive y is down, and give it 100. I think that's the value I used. So everything's going to fall down to the ground there. Anything that's in this physics simulation, see that? It's going to just drop right down there. It has a little positive x velocity there, so let's get rid of that. We can do that here. After we create the dot and we add it here, let's do dot body dot velocity dot x is 0. This we don't want it to move sideways. It's what the heck is going on? How come it's, why does it come? Oh, I know why. Because it's inside. See, you can look at it as a 64 by 64 box around that, and it's doing collision based on the box. So we instantiate it, and the box is intersecting the border of the world, and that's pushing it away. So it's giving it some velocity, some initial velocity. So we need to instantiate the sprite farther away. So let's do that. It's right here. Let's give it the position, 70, 70, like that. So now it should just fall straight down. There it is. See that? Now it doesn't have any initial velocity because now if I click here, it's going to be pushed away. Do you see that? Because, see, watch this again. Because the collision box around the sprite is overlapping the world boundary. And the physics system is freaking out and saying, that's not allowed, it's against the laws of nature. And so it pushes it, tries to adjust its position to get it inside the world. So it shoots it in there. It gives it some acceleration, actually. And then it flies into the world. You can see it's accelerated, and it slows up. Some friction there. See it stop right there? So that's 64 by 64. It hit that border of the world. Now you can turn that off. If you look at this world here, watch this. You can turn, or maybe it's part of the physics system. Let me think. Or it could be part of here. There's something to do with the bounds, world visible. There's a way to keep things constrained in the world, and there's a way to let them exit the world. So anyway, it's turned on by default. I think I'll just leave it alone for now. I'm going to play with that. We're running out of time. So what I want to do next is, and we'll resume upstairs. I want to talk about the kinematic, there's like users. When you have a user play in the world, you use what's called a kinematic rigid body, as opposed to a dynamic rigid body. So this thing is a dynamic rigid body, although we are modifying its position. But after we modify its position, it's just subject to the laws of the physics simulation. But a player controller doesn't work like that. I mean, some of them do. A lot of player controllers, they interact. They have collision issues. You can't move your player through a mountain like that, so there's collision. But its position and its velocity is controlled by your controls. Your keypad, your controller, your mouse button, and so that's called a kinematic static body. It has the physics system exerts partial control over the body. It enforces collision in particular, right? It doesn't let you violate collision constraints, but it does not apply the simulations of forces in the world. So you, as a kinematic body, assert force. You're like an infinite mass. So when you hit a ball, you're going to push that ball away. So that's called a kinematic rigid body. I'm going to show you how to do that. A lot of games basically use that setup. So we'll do that upstairs. We'll resume upstairs.